This is the Lone Crater YouTube. We hope this video helps.
You start by validating prerequisites and taking immediate measurements. Confirm dataset format and an 80/20 split so experiments are comparable. Once done, run a quick baseline latency benchmark with a fixed input set to capture current delays. Make sure to enable profiling hooks and timestamp logs at data loading, model inference, and post-processing. This gives you the objective metrics you need to prioritize fixes because you cannot optimize what you have not measured precisely. You now address the complex middle steps. Reduce model compute via pruning or quantization, testing FP32 versus INT8 to balance accuracy and delay. Then rework the pipeline. Introduce batching, caching, and asynchronous I/O to cut per item overhead. Ensure batch sizes match latency targets. Profile GPU and CPU utilization concurrently and adjust worker threads, prefetch counts, and memory pinning to remove stalls. Make sure to iterate. Change one variable, measure impact, and keep the configuration that lowers end-to-end delay. You finish by deploying the optimized model to the target hardware and validating end-to-end latency under realistic load. Confirm accuracy remains acceptable. Once stable, add graceful degradation. Smaller batches or lighter model variants when load spikes. Make sure monitoring and alerts capture latency regressions. If something goes wrong, a reliable troubleshooting tip is to revert the last single change and rerun the targeted benchmark. This isolates the cause quickly, because incremental rollbacks reveal which tweak introduced the regression.
Thanks for watching. Consider subscribing if we helped you.